Hello, today we're going to be talking about page 6 of your chapter 16 notes, and the title of this lesson is At Least and At Most. Well, this follows the last lesson that we did on probability, was the probability that something occurs exactly a certain amount of time. If you remember from page 5, we talked about getting or flipping exactly 2 heads, or rolling exactly 2 threes on a dice, or the probability that exactly 3 cards were read. Everything had exactly in it. But now what we're going to do is do the same idea, but this time our problems will be saying at least a certain number, or at most a certain number. So you just have to kind of think for a minute, what does it mean to be at least 5? Like if you come up to me and say, I'm going to spend at least 5 minutes doing the math homework tonight, at least means 5 or more. But if you come up to me and say, I'm going to spend at most 5 minutes watching the video tonight, I hope that never happens, but at most 5 means 5 or less. Usually it means 5 down to 0 in most cases. So keep that in mind. Now when we have these kind of probabilities like we did on the last lesson, we're going to be doing this, we're going to be using the same formula, which is, I'll write it down here, you should write it down here, NCR times P to the R times Q to the N minus R. That's the formula. But when we're going to be using the formula, when you have the phrase at least or at most in it, we're going to be adding the probabilities starting with R is equal to 5 in this case because it's at least 5. Before it said exactly 5, so when it said exactly 5, we set R equal to 5. But R, when it says at least 5, R is equal to 5, 6, 7, all the way up to whatever the N value is. So it's going from 5 up to N. And if we're trying to find the probability of something happening at most 5 times, 5 or less means 5, 4, 3, 2, 1, and don't forget 0, 0 times. So that's what it would mean to be 5 or less. Or if it was 3 or less, it would be 3 down to 0. But it always means go down to 0. So you go down to 0 for an at most problem. So in this first example, a coin is biased. If you have a biased coin, it means that you don't have a 50-50 chance of flipping heads. So we have a biased coin, so the probability of flipping heads is 3 out of 5 instead of 1 over 2 because it's biased. So what's the probability of obtaining or just flipping at least 3? So we're going to circle the phrase at least 3 in this problem. So we know that R is going to be at least 3 or more heads in 4 tosses of the coin. So what we need to do is put our N, let's see where we're going to put it. Let's put it here. N, R, P, and Q, those 4 values. N is the total number of tosses of the coin, which is 4. R is the value that comes after the word at least. At least 3 means 3 or more, 3 all the way up to N. Well, N is only 4, so we're only going from 3 to 4. The probability of getting heads is 3/5. So 3/5 plus 2/5 is equal to 1. So we have those values. Now what we're going to do is we're going to add probabilities. Oops, IES. We're going to add probabilities together when R is equal to 3 and R is also equal to 4. So what this means is we're going to say, let's start with R equals 3. We're going to say NCR, which is 4C3, times P to the R, which is 3/5 to the 3, times Q to the N minus R, which is 2/5 to the 4 minus 3 is 1. And we're going to add to that Now we let r equal 4. So now we have NCR, which is 4C4, times p to the r, 3/5 to the 4th, times q to the n minus r, 2/5. 4 minus 4 is 0. So we can put this whole thing on one line of our calculator, and I would advise you to do that and don't split it up. And it'll go like this. Hopefully you have a calculator that you can follow along with. So we have 4 math PRB NCR 3 times, I'm going to use the fraction button, 3/5 to the power of 3, and then we're going to have 2/5 to the power of 1. So this is the probability to have exactly 3 heads, but we also want to add to that because it could be 3 heads, or you could flip 4 heads to be at least 3. So now we're going to do 4 math PRB NCR 4 times the fraction 3/5 to the power of 4 times the fraction 2/5 to the power of 0. So hopefully you followed along with all that, or maybe just pause and rewind the video if you need to get to a particular part of this entry. So when you hit enter, you're going to get the fraction 297 over 625. So if you look through all of those multiple choices, you'll see that option 4 matches our answer. That's the end of that problem. On number 2, a fair die is tossed 4 times, so that must mean n is equal to 4 on both of these examples. So let's just write them down in both places. Now we also need r and p and q. Now if you want to find the probability that you'll have at least 2 1s, well, r must be equal to 2 because you write that same number down, and at least means 2 or more, just like the previous problem. So r is equal to 2, or it could be equal to 3, or it could be equal to 4, but do not go past n. Don't go past go. All right, so that's our value. Now, what is the probability that on one toss of a die that you will get a 1 showing up? The probability is 1/6 on one toss of a die. So 5/6 plus 1/6 is 1. So now we have 3 probabilities to add together. R equals 2 and 3 and 4. So we have NCR times P to the R times Q to the N minus R plus NCR, now we're letting R equal 3, times P to the R times Q, this is a 3 not a B, to the N minus R, which is 1, and then we're going to add to that 4C. Now R equals 4, because you could get 2 1s, 3 1s, or 4 1s when you toss a fair die 4 times. Times 1/6 to the 4th times 5/6 to the 0 power. And I'm writing uphill. Must mean I'm an optimist. All right, so math, PRB, oops, let me quit out of that because I forgot to press 4. 4, math, PRB, option 3, 4C2 times, I'm just going to do 1/6 to the power of 2 times 5/6 to the power of 2 plus 4 math PRB option 3 4C3 times 1/6, hopefully I'm putting everything in right, to the power of 3 times 5/6 to the power of 1 plus 4 math PRB option 3 4C4 times 1/6 to the power of 4 times 5/6 to to the power of 0. That was a lot, but that's it. You get that decimal, and now I'm going to see if I can math frac it because I didn't enter my probability as a fraction. I'm not getting a result as a fraction, but you could do that. It's 19 over 144. So if you toss a fair die 4 times, the probability that you'll get at least 2 1s will be 19 over 144. So this is handy when you go to Las Vegas or Atlantic City. All right, part B, at most 1. So at most 1, remember at most means 1 or less, so you're going to go down to 0. So R is equal to 1 or 0. And now we want to find a probability of you getting a number greater than 4 on one toss of a die. What is the probability? Well, if a number is greater than 4, then you will be rolling either a 5 or a 6. And what is the probability of getting a 5 or a 6 when you roll a die? Well, there's 2 out of 6 because you either get a 5 or 6 out of 6 chances. Or if you wanted to reduce that down, you could. You don't have to, though, but we'll call that 1/3, and Q is equal to 1/3 plus 2/3 is equal to 1. So now we have 2 probabilities to add together because you have 2 R values. So you have NCR times P to the R times Q to the N minus R. 4 minus 1 is 3. Plus NCR, now R is 0, so 4C0 times P to the R times Q to the N minus R. 4 minus 0 is 4. So let's put that in our calculator. 4 math PRB NCR. 1 times 1/3 to the power of 1 times 2/3 to the power of 3 plus, plus 4 math PRB NCR 4C0 times 1/3 to the power of 0 times 2/3 to the power of 4. And that'll give us a decimal, and let's see if we can math frac that. And that looks like it's 16 out of 27. So you have a 16 and 27 chance. That's better than 50-50, it looks like, of getting at most one number greater than 4 when you toss the die 4 times. The next example, Peter has a 40% chance. That means his probability is at 40% of making a 3-pointer. If he shoots 6 3-pointers in a game, what's the probability that he's going to make at least 4 3-pointers? So we have an N, R, P, and Q. Now the N value is how many times he shot the basketball, and it looks like he shot the basketball 6 times, so we've got N is equal to 6. And at least 4 means 4 or more. So he could shoot 4 or 5 or 6 and be successful. The probability that he's going to make the 3-pointer is 40%, so we'll call that 0.40 or 0.4 or 2 out of 5. And the Q value is 60%, so 0.60 is a 60% chance. And now what we're going to do is add 3 probabilities together with 3 R values. So we have 6C4 times P to the R times Q to the N minus R plus 6C5 times P to the R times Q to the N minus R. 6 minus 5 is 1 plus NCR times P to the R times Q to the N minus R. Let's put that in our calculators. 6 math PRB NCR 4 times 0.4 to the 4th times 0.6 squared plus 6 math PRB NCR 6C5 times 0.4 to the 5th times 0.6 to the 1st plus one more 6 math PRB NCR 6C6 times P to the R times Q to the N minus R, and then hopefully we got everything in there, and we'll math frac that answer, and we'll get 112 over 625, where you can say 17.92% if you want to. So it's 0.1792, or because they gave us the answer in percentage, we can say 17.92%, or if you want to write it as a fraction, our calculator math fract it to 112 over 625. So any of these three answers is correct. At most 3. So we are still shooting 6. Our R value is at most 4. So at most 4 means 4 or less, 4, 3, 2, 1, or 0. The probability is 0.4. The probability of failure is 0.6. So I already have the 6C4 in there from the previous one. I'm going to have to add 5 probabilities together. So we have, this is a long one. We have 6C4 times 0.4 to the 4 times 0.6 to the 2 plus 6C3 times 0.4 to the 3 times 0.6 to the 3 plus 6C2 times 0.4 to the 2 times 0.6 to the 4 plus 6C1 times 0.4 to the 1 times 0.6 to the 5th plus 6C0 times 0.4 to the 0 times 0.6 to the 6th power. It's a lot. All right. So I'm just going to pull up the old thing that I put in there before, because I think I already have the 6C4 in there. So we've got 6C4 times 0.4 to the 4 times 0.6 to the 2. Now 6C3 times 0.4 to the 3 times 0.6 to the 3 plus 6C2 times 0.4 to the 2 times 0.6 to the 4 plus 6 math PRB NCR 6C1 times 0.4 to the 1 times 0.6 to the 5th plus 6 math PRB NCR 0 times 0.4 to the 0 times 0.6 to the 6. And then that'll give us, wow, 95.904% chance. 95.904% chance, which is 0.95904 out of the calculator. Or if you want to math frac that, it would be, holy cow, 2997 over 3125. Oh. 2997 over 3125. Holy cow. Now, no 3-pointers. If you don't want to have any 3-pointers, well, he's still shooting 6 times, but he wants 0 3-pointers, so R is equal to 0. And what's his probability of shooting a 3-pointer? 40%. Nothing changes except for the R value. So now all we have is 6C0, 6 math PRB, 6C0 times 0.4 to the 0 times 0.6 to the 6. 6C0 times 0.4 to the 0 times 0.6 to the 6. And that would be 4.6%. Oops, and it doesn't math frac. So this is 0.046656 which is equal to 4.6656%, if you want to write it as a percent. And then the last one, exactly 6. So he's shooting 6 times. What's his probability that all 6 of them are going to go in? Well, whoops. His probability is 40%. So this is 6C6 times 0.4 to the 6 times 0.6 to the 0. So all I have to do is overstrike the zeros with 6's. And the 6 to a 0. And he has a 0.4% chance. Let's see if that'll math fact. Nope. That's equal to 0.004096 or 0.4096%. And that's the end of the show. See you tomorrow or the next time I meet with you.